Morning, everybody. It's local time 7 o'clock in São Paulo, so we're preparing for our turnaround flight to Buenos Aires Asia Airport. The airplane just arrived, so we're doing our flight preparation here and wait until we can board the plane. Roman and I decided that I fly to Buenos Aires and he will do the flight back to São Paulo. Okay, let's attack the papers. What do we have? Weather information. National toy. Flight plan to Asia. Flight plan back. Okay. Now that's nice. Satellite picture. So we are somewhere here. The Rio de la Plata, Buenos Aires. Looks like we have very nice weather today, all the way down, especially in the south. Isolated low clouds over the sea, and still some thunder showers left in the vicinity. What's that? The next one? Same one, other time. Overall weather situation from that's Curitiba, Galeão, somewhere here. Montevideo this way down, and on the way back we go to Porto Alegre and then over the beach this way. So only some low clouds left, stratus scattered, isolated thunderstorms embedded, nothing special. That's the big map, it's clear. Checking the winds. Oh, that's all we have. From today, 16th January, flight level 300 is a little bit low. Looks like about 30 knots headwind component. 5, thank you. That's more realistic, 340. Yeah, it's difficult to say. 390. Now there's more wind. Would be a good reason to stay at 350, might be. Instead of, I think the flight is planned at 390. But it looks there's more wind up there.
390.
Okay. Can you give me the arrival time for São Paulo?
For São Paulo?
Yeah, back time.
It's 17:10.
17:10.
And 12:55 in Ezeiza.
Okay. Sao Paulo forecast from the 16th. 24-hour forecast from 6 to 6. We have a wind of 130 at 5, 8 kilometers broken at 1000. Prop 30 from 8 to 11. That's now 4000 Brüm. Broken at 500. Yeah, that's the low clouds. Becoming for us starting at 14. More than 10 scattered at 25, and temporary after our arrival isolated thunder showers, few CB. So if we are lucky, we have a nice flight also back to Sao Paulo. In our alternate, we can quickly check it. Campinas. Also 16th 24-hour forecast, 140 at 10, good visibility. Also late thunder showers. Good, huh? Rio is fine as well. Buenos Aires. From today, 24-hour forecast, 140 at 6. Runway 11.
Road runways.
No. Okay. Probability of 30% from 8 to 10, 5,000 with mist. Okay, just short information. Flight time to Buenos Aires is 2 hours and 20 minutes. And the weather is very nice all the way, especially in Buenos Aires, so I don't see any problems from my point of view. You have, I think, a good football team in the business class, so let's hope that they don't start playing football in the business class.
No, they won't.
No. And otherwise, no news from my side.
We have full house
full
coming
house,
back, so that means that it's going to be very tough for us because we
Very
have one
tough.
minus one person.
Yeah, one sick flight attendant.
Do you know that the flying time going back?
Roman knows everything.
Okay.
Roman, flight time on the way back?
Is it going to be 2.5 hours? Or
No, about 2 hours, I would say. It's not. It's 2.
2 hours.
2 hours, yeah.
So try to eat something on the way down
Okay.
to Buenos Aires.
Yeah, we'll make self-catering.
Self-catering, eh?
Okay.
So
Is
we
the
go
plane
on
ready?
board.
Okay.
We have everything done.
Cockpit work and the captain's duty is to basically check the aircraft log, check cabin log, and prepare the flight management system for the flight. Let's start with the cabin log. Cabin log is electronic. We have a laptop which should get more and more functions implemented. Right now it's just an electronic cabin log. I can not make too much up to now because the mechanic is still busy, but I see that we have a damaged galley door and a reading light, so there's nothing special for me. Point of view electronic cabin lock. I have to open it then later on when the mechanic is back. Also I see the aircraft log is still open. So let's start with the flight management system. May I borrow the flight plan? Our flight plan shows in this section basically the input we have to do in the flight management system. So we start usually with the aircraft status page. Let's see that the database is current from 25th December until the 22nd of January, that's correct. And the performance factor is plus 4%, which is also correct according to our flight plan. Now we are planned on routing number 1 from Buenos Aires, from São Paulo of course, to Buenos Aires. I can enter that this way. Go from a uniform to Asia routing number 1. I have no alternate route I want to insert. Our flight number is 0094 and the planned flight level is 390. Temperature level minus 54 centigrade and the tailwind component of, a headwind 35 knots. Cost index of 80 is correct, and now we check the position. I see outside we are south 23 degrees 25.7 and west 46 28.8, which is correct in here. So I initialize the inertial reference system here, so the platforms will be aligned now for our current position. So this page is correct. Let's go on one page further, the so-called weight init page. I have to adjust the taxi fuel. I put in, just to compare it with our planned figures, the initial contingency fuel of 0.8, which is a 5-minute contingency fuel and alternate fuel to Montevideo of 4.3. For me it's just a basic setup that I can check our flight planning with the flight management system. The rest I have to wait for the load sheet, so let's go one page further. Refuel quantity is 30, that is wrong, that has the mechanic. I clear that now. No ballast fuel required. We have jet A1 fuel, that's important for the freezing temperature of minus 47 degrees. So let's go to the flight plan page. Flight plan is already inserted now. Besides standard instrument departure and arrival, I can activate here the SID, which is today, let's wait 1 minute.
Last fuel is gone.
Yeah, I cleared it. Expecting departure runway is 09er left, that's the long runway here, and then we make an immediate right turn back to Congonhas. That's a so-called Tony departure, and thereafter a SARA transition on runway 9 left, of course. So it's all selected and inserted now, and we already see it on the nav display coming up. So we start to check it. runway 09 left, at 500 feet a right turn to Tony with a maximum altitude of 900 and a speed of 190 knots. Then to Congonhas with a minimum flight level 100. Sara. Thereafter I have to get the flight plan to check for the further routing, which is Solid, Ponte, you can see it also here, Solid, Ponte, Curitiba, Mopex, Gache, Magic, Page, Isala, Dalgo, Durazno, Ponpa, Papix. That's already in the arrival. So let's check for the arrival from Papix. I want to make a standard arrival route onto an ILS runway 11. That's a Papix 6 Alpha arrival without the transition. Then insert it. Now he asks me for the procedure. We take the procedure November 02. And now we see that we go from Papix over the field, over Asia straight. And then we perform a base turn to the south, 10 miles out, and then a right base at 2,200 feet intermediate approach altitude for runway 11. And a missed approach. So the flight plan is correct. Now we make a cross check. Distance 965 miles, which is correct. I can clean up further. Let's fix some nav aids. VUR1 on Congonhas. I take it on number 1. It's better. I check the performance page, which is on standard econ climb. I just checked the descent, 290 knots policy speed. No fixes inserted. Secondary flight plan, which is just using memory right now, is non-inserted. That's correct. And the takeoff page is prepared by the first officer when he has checked for the performance. So I check if there is an engine out procedure. There is none. So we have to define our own procedure and follow the SID. So far the flight management system is now set up. Let's wait for the papers here and continue then with our internal cockpit preparation. Where are my maps? Here. Okay, the routing here on the map, which is a little bit difficult to see the sea, that's more or less the coastline. This is São Paulo, Guarulhos. Here is Rio de Janeiro. So we will fly over Congonhas, then to Curitiba, and follow that airway, the upper Alpha 318, to Isala, that's the border to Uruguay, Durazno, and Papix, which is over the Rio de la Plata already, and FIA boundary to Argentina, and Buenos Aires is just behind. The way back then will be a little bit more south, over Dorbo. Down there is Montevideo, our alternate, by the way. So we fly from here to Melo, a little city, then into Brazil, Porto Alegre at the coast, Florianopolis, and then over Santos at the beach into São Paulo. Sometimes there is a shortcut which saves a few minutes from Porto Alegre straight to the Petri point, where the arrival procedure starts for São Paulo. Flight time today 2 hours and about 30 minutes with the headwind down, and 2 hours with the tailwind back to São Paulo. Okay, it's my pleasure now to give you some overview about our cockpit layout in the MD-11. Let's start with the electronic flight instrumentation system. Basically, the MD-11 is a derivative of the DC-10, so the hardware is really old-fashioned, but the cockpit is very sophisticated and is mainly dominated by 6 large CRT displays. So let's start from the left side. Left-hand side we have the so-called primary flight display with standard setup, attitude, speed, compass arc, vertical tapes for the altitude and the vertical speed. Additional information is the flight mode annunciator in the top. Here is an ILS frequency. You see the green marker for the track, ILS information, QNH, and current altitude. So that's a standard setup here. To the right, the so-called navigation display. Navigation display has 5 different presentations. Here we see the so-called map mode. That means the map is oriented according to aircraft heading or aircraft nose. You see the aircraft in the center heading up. In the magenta colors are all flight management derived information. So the flight plan, which shows here the right turn, of course, at 2960 feet to that Tony point, and then if I increase the range to a 10-mile range, 20 range to Congonhas, and then further on. In the background you see the information here in brown and red from the enhanced ground proximity warning system. Other informations here is the navigation mode, which shows that we are on GPS inertial, which means that we are navigating with GPS primary. In the little window here I can select information I want to have in the display, which means I have the traffic alerts. As you can see, it has disappeared now. All the datas, like the limitations here over Tony, I can select those datas away and they disappear. I can deselect the traffic, I can deselect airports. So it's the own choice of information. That's the standard setup. Sao Paulo as an airport with a little star. Data, of course, and I see the limitations I have at this Tony point, and of course from the TCAS the traffic alerts selected directly on the nav display. What else? Of course, compass rose, track pointer, wind information then we can see in the air. Down the selected navigation aids, now 2 VORs displayed on the needles, blue needle, green needle. I can also switch to ADFs, nothing selected here right now. So let's stay on 2 VORs. Another mode is the so-called plan mode. It's basically used to check the flight plan. The whole display is now north oriented. North is up, and you see again here the plane. And that allows me to scroll through the flight plan. I will first increase the range a little bit, and then I can jump to the flight plan as I'm scrolling in the FMS and visually check our routing. Curitiba here below, as I did before when I checked my entries in the flight management system. And so already arriving here in Buenos Aires. There are also so-called VOR mode, rose mode, seldom used, only during VOR approaches, non-precision approaches, which is a classical rose mode, VOR needle, deviation bar, VOR information, and quite similar to the so-called approach mode. Here is the ILS in Sao Paulo on runway 09 right with the deviation bar and the classical rose mode. Here we see aircraft information from the TCAS. And the last page is the so-called TCAS. If we have a traffic alert, we select the TCAS button, which mainly gives us the smallest range, 5-mile range on the display. It hides all the navigation information and gives us the stars showing the hours of the clock, so that we immediately can find and locate an intruder and conflicting traffic. So I think that's the most important information about the navigation display. Of course, the first officer has the whole setup once again, the navigation display and the primary flight display. Navigation display, he can choose his own displays and presentations. Then the next in the middle, this one here is so-called engine and alert display. It means we have primary engine information, 3 engines, engine pressure ratio, exhaust gas temperature, revolution of the low pressure compressor or turbine and of the high pressure compressor turbine N1 and N2. Here's the information that the fuel switch is off, and the fuel flow indication will be digitally displayed below. The lower section is the alert section. So here are all the warnings displayed, several levels of course, red warnings which require immediate awareness and action, amber warnings in 2 levels, and blue warnings more as information. So the door open is a so-called level 1 warning, of course, right now on the ground, and here the blue warnings are mainly from the air system, that the cabin doors are open, that the communication VHF number 3 is on the voice, and that the no smoking sign is on. Here is a so-called memory section. That means I have to check the configuration page for additional warnings. On top, the thrust setting. Today, as we are very light, the first officer has checked we can do a so-called reduced takeoff thrust. The MD-11 has the ability to select between 2 different thrust settings for takeoff. A 62K, that means 62,000 pounds thrust. We can activate for heavyweight takeoffs, and the standard setting is 60K takeoff, 60,000 pounds of thrust. And now we have a reduced setting, as we have inserted a 44-degree flex temperature, gives us an EPR for the takeoff of 1.49. Total air temperature in the upper corner. So this is our primary engine display. There's no other function of this screen. In the middle, of course, gear indication with the center gear, gear handle, possibility to isolate the center gear. That's important if we have to make an emergency landing with one main gear, the left or the right main gear, retracted. The center gear cannot bear the load and has to be retracted then. This screen is the so-called system display, which has about 8 different screens. Right now, the secondary engine page. Secondary engine page mainly a gross weight information as soon as we have inserted the weights. Total fuel, stabilizer position, CG position, cabin altitude and cabin rate. In this corner, from the auxiliary power unit, main information, and then for the engines, oil pressure, oil temperature and oil quantity, engine nacelle temperature, vibration monitoring for the compressor and the turbine section, and of course here then also the alert section. Now I can switch from the engine to the hydraulic page, so I can display all the aircraft's main systems, like here the hydraulic system, which shows 3 tanks, 2 hydraulic pumps, engine driven per tank, and the system pressure. We have the possibility to transfer pressure via so-called reversible motor pumps from system 1 to 3 or for system 2 to 3. In addition, we have 2 electrically driven pumps. One is also driven by the air-driven generator we can drop in case of an emergency. The next page is the electrical system page, which shows the whole electrical system right now. Information from the APU with the voltage, frequencies and load. On this level, the generators not running, of course, right now, as the engines are not running. On this level, the AC system, from left to right, it's a left emergency AC bus, an AC bus 1, AC bus 2, ground service AC bus 3, and right emergency AC bus. And the upper level is the DC system, as well, left emergency DC, DC1, DC2, ground service DC, and DC3, right emergency DC bus. The fourth display is the air system. Air system mainly from 3 engines, bleed air. Engines are not running right now, so the air, as you can see on the green lines, is coming from the APU. Via these cross bleeds, we can transfer the air from system 2 to 1 and from 1 to 3. Here you will see usually the pressure in the system and the pre-cooler outlet temperature. Up here are the so-called air conditioning packs with the pack outlet temperature of 2 degrees. The air is quite cold and will be not shown on this screen, additionally heated with hot bleed air. Up here you see the distribution, the temperature of the air as it enters the sections. 1 cockpit section and 4 cabin section. In blue is our pre-selected temperature, and in white the actual temperature of the compartment. Below, cargo compartments as well with temperature selection and actual temperature. What we can do in there is as well to show the cargo fire detection system. As you can see here, smoke detectors, heat detectors in the lower cargo compartment. Next page is the fuel page. MD-11 has a very sophisticated fuel system, an excellent fuel system controller. Basic setup: main tanks, left wing, center tank, tank number 2, a right wing tank, and then a huge auxiliary tank which is more or less located around the center tank, and in addition a tail tank in the horizontal stabilizer, also used for CG trimming. A lot of pumps not running right now, just one AC pump is now running to feed the APU. Up here the engines, fuel flow information and fuel used information. Next page, the configuration page. Primary shows all the wheels with brake temperatures and tire pressures. Up here the airplane, where we can check the configuration. Let's say flight controls, position, surfaces, and in addition a so-called secondary gear indication. You can see the 4 wheels here showing green. Stabilizer position in the corner. The last pages, status page, is used to display all current warnings, so it's a good page to have an overview about the technical situation. And another page, a so-called consequences page, now showing empty. If we have any technical problem which is displayed with a warning and has consequences, it's listed here on the consequences page. I think that makes the first overview about our flight instrumentation. We have the opportunity to see the navigation system later on.
Jeep 904, red copy.
Red to copy, go ahead.
Yes, with Zeta, flight level 350. Array up at Alpha 318. Tony departure and Sarah transition. Clock 3371. São Paulo departure 135.75.
Roger, copy to Buenos Aires, Upper Alpha 318, flight level 350, Tony, departure, Sarah transition, and squawk 3371, frequency 135.75, Swiss 94.
Alright, sir, propulsion start to enter the small 7.
Abram, bon dia, the Swiss 94, understand, Hotel 06, ready, stand and push.
Swiss 94, wireless ground. Clear to start up, then push back. Report you at the taxi.
Clear for start and push, and call you for taxi, Swiss 94. Clear, start and push.
Go around here.
Affirmative. Starting all.
Complete checklist.
Okay, all engines clear.
Start all engines.
Parking brake, please. Parking brake set.
Guarulhos mais 4264. Prossiga para a sala.
Aileron deflection.
Slant extender. Flaps.
That's very interesting. We drop also our ailerons to assist in the lift for departure and use them like flaps.
Delta 105, change your taxi. Bravo, Hotel Alpha, hold short off, Golf.
Deflections. Down. And rudder. Microphones checked.
Fuel switch.
Fuel switch is checked.
Okay, signal.
Receive.
Swiss 904 for taxi, please. Ground, Swiss 904 for taxi.
Standing by for taxi, Swiss 904.
Standing by.
Meantime, we can make the APC clearance up.
Okay.
Ready? ADC clearance, Tony departure, Sarah transition is inserted in the flight management system, which means straight at 500 feet, then a right turn to Tony, maximum flight level 90, speed 190, then to Kokorimon. Continue to Sarah.
Varig 2306, continue taxando Bravo e aguarde.
Bravo, guarda.
3371 is set, departure 3213575.
Swiss 94, approved taxi via Hotel Bravo Golf on holding point 09, to the left, call tower 132.75.
Hotel Bravo Golf to 09 left and 32.75. Swiss 99.
Right, sir.
Swiss Air 95, observe your Airbus and pushback.
Yeah, after the Airbus Swiss 904.
Tá 3556, após a passagem do MD-11 da Suíça, autorizado Hotel 9.
Após Suíça, Hotel 09, tá 3556.
Order there.
Varig 2306, após a passagem do Suíça, seguir o TAM para o Hotel 10.
Hotel Bravo Golf.
Após o Suíça, segue o TAM para o Hotel 10.
It's nice, you're number one everywhere. Right. Taxi check, please.
Spoilers. Armed. Its clearance is very
Verify navigation for
right side still clear. Like a briefing.
position speed is 130. Stop, reverse. Is that way you can unreverse, 80 knots, idle,
Okay.
and then off.
Also Kabinengel ist
Danke,
secured,
ja.
wünsche einen guten Start. Gell?
Okay.
We go straight ahead initially for the cleanup. Terra-wise is no problem. One successor, and then we return back right to one successor.
Guarulhos, Brown Cantina, 1249, gate 06, you're ready for pushback and start up.
Argentina 1249, should start up then pushback, report you at the taxi.
Report ready to taxi, Argentina 1249.
Okay, so pitch to control is positive.
Guarulhos Tower, to Swiss 904, we are ready. 09 left.
Swiss 94 clear for takeoff, 290 degrees, 6 knots.
Clear takeoff, 09 left, Swiss 904.
Okay, ensembles are on pick plates rust. We have flex 44, axle flaps 22. 22 degrees.
Check.
And 44.
That box is
EAD
clear,
green box.
and EAD green box is clear.
Cabin is secure, first part complete. And flight attendants
Port.
and passengers off. Taxi check complete.
Ready?
Fuel is checked, time is okay. And ready.
09 left, starting in. Headings are coming fine. Headings checked. Take off.
Vectors are set.
Checked. Checked.
We won. Rotate. 3, 2.
Get up.
Torre Guarulhos, bom dia. UASI 4264, aproxima-se do ponto de espera pronto.
Sway 094, airborne at 37, São Paulo, departure 13575.
3575, so long, Swiss Standard.
So long, last 42, 64, autorizado.
Go following range.
Level 350.
Climb and maintain 350 unrestricted Swiss 9. Swiss 94, confirm unrestricted flight level 350.
I will maintain 350, restrict.
Swiss 94.
Flaps up. Checked. That's it.
There's nothing here. Swiss 94, contact 1349.
349 is Swiss 94. São Paulo radar, get it, the Swiss 94, out of land 5 planning, flight level 350.
Swiss 94, where is Silver? Time to flight level 350.
Flight 350, Swiss 94.
Fly nicely. Check anytime. Which is cruising now at level 350, approaching Curitiba. I have time to explain you our overhead panel. We start at the top left, which is a small cargo fire panel, mainly to control the cargo fire extinguishers. And we have two bottles we can discharge either in the forward or in the aft compartment, controlled by these buttons. Just below is the evacuation signaling system. In case of an on-ground emergency and evacuation, we can activate the evacuation signal, which basically produces an alarming sound. It's quite loud. I can stop it with this button in the cockpit, that we can continue to work normally. One below the panel for the inertial reference systems, we have 3 inertial platforms, which are quite easily controlled by these 3 buttons. System 1, 2 and an auxiliary number 3. Once below, the cockpit voice recorder system, cockpit microphone, area microphone, and test buttons, possibility to erase the last recording. Once more below, an electrical part, just a sub part. We never use these buttons. It generates the bus reset used by the maintenance, but we can switch the galley powers off. Galley 1, 2, 3, kitchens behind, we can switch the power off. Below here, cargo temperature control. We can actively control the forward and the aft cargo compartment. Forward just with low and high position, and the aft cargo we can precisely select a temperature. Once below, our newest system, it's a standalone system, not integrated in the aircraft. We will discuss later. It's our smoke detection system in the avionics compartment, but also in the cockpit and galley overhead areas. As a result of the Halifax accident of '98, we will discuss that system later. Here is the full authority digital engine control panel, FADEC in short, which primarily controls the FADEC system for the 3 engines and the normal engine ignition. We have 2 circuits, channel A, channel B, or an override position. Here below, windshield wiper switch, rain repellent is deactivated, and in this corner an alternate emergency stop switch for the fuel dumping circuit. So this concludes the left hand part. Now we switch to the center. We go up very high. Of course, here 3 fire handles to extinguish engine fires for each engine. Each engine has 2 fire extinguishing bottles, which are indicated just below by the agent low lights for each engine. Now below, our system controllers. I have to give a little forward. That's a very special part of the MD-11, that we have fully automatic system controllers, which are able to control also failures and reconfigure the systems automatically and just deliver an information about the new status to the cockpit crew. So we are here with the hydraulic system controller, which is now dark. That means that the system controller is working fully automatic. Here the switches for the engine driven pumps, switches for the reversible motor pumps to transfer the pressure from one system to another, and here the indicator lights for low system pressures. Below is the electrical system controller, as well as many buttons to control the electrical system. In a manual mode, we can switch every system with the main switch here to a manual mode and control the system manually. But now it's also all dark because it's in automatic mode. Main points you can see here: generator, relays, disconnection of the constant speed drives of the generator, indicator lights for the AC system, indicator lights for the DC system, battery switch, emergency lighting, and to the far left a very special switch, our smoke electrical control switch we uses in case of smoke of unknown origin. With this switch, which has 3 positions, it depowers on each position 1/3 of the electrical and 1/3 of the air system. So it's our best means to immediately isolate a possible smoke source. Let's go one down. The air system, also in fully automatic mode, all dark, bleed control switch, interconnection via the cross bleeds, 1-2 isolation valve, 1-3 isolation valve, and these switches control the temperatures in each compartment. We have some amount of recirculated cabin air, which is controlled via an imaginary pax load figure. Below there, the fuel system controller. It's my favorite system controller. It's very sophisticated, mainly to control all the pumps, all the fill valves, and all the cross-feed valves of the fuel system, with fuel quantity indications as a backup up here. This switch is the fuel dump switch. We can dump our fuel with a rate of 2,600 kilograms per minute, which is quite high. The fuel is dumped overboard at the wings. Just below, some different switches, mainly lightnings, emergency lighting, no smoking signs, seatbelt signs, landing lights, our public address systems, our attendant call and cabin communication system, and below secondary lights, turn-off lights, navigation lights, our logo light, the beacon, high intensity light, and so on. Now let's move up again on the right hand side. This belongs to the before mentioned new smoke system. It's standalone miscellaneous smoke alarm, where we have the horn and the cutoff for the horn. Below is the APU panel, APU fire extinguishing. The APU can use either its own bottle engine number 3, or it can use the 2 engine fire bottles of engine number 2. And here is the control switch for the APU. Below here, our famous kitchen clock, very useful. To the right, ground proximity warning system with the possibility to cut off the flap mode in case of limited flaps approach. Below here, the flight augmentation systems, mainly the yaw damper and the longitudinal stability augmentation system. That's a very unique system which had to be introduced from the DC-10, as the stabilizer is about 40% lower than the stabilizer of the DC-10. So we need an additional stability augmentation system, which is controlled here. Below here, the cabin pressurization system in an automatic mode, 2 controllers in the background, and the possibility to control it manually. Further down here, anti-ice controls for the engines, wing and tail, windshield anti-ice control and defogging. Below, some additional switches, annunciator light testing, cargo door testing, fuel use resetting, engine max point resetting, and of course first officer's windshield wiper as well. I think that concludes the overview for the overhead panel of the MD-11.
That's how it works.
So we're still cruising at level 350 and reaching a position north of Porto Alegre. I take the time to explain you the center pedestal of the MD-11. Let's start in the middle in the front. Obviously we have two so-called MCDUs, multifunctional control and display units. With these units we control all our flight management computers. We have two flight management computers and they operate independently. There is a crosstalk between the two systems, so from each position we can make any inputs to the system. Basically we have the lateral and vertical navigation and performance calculation in here in the flight management computers. In between you see our new so-called secondary flight instrumentation. This new primary flight display was inserted after Halifax. We had mechanical emergency instruments, and this one is brand new, with more information, speed, altitude and heading and attitude, and has a 40-minute autonomy by backup power from an inertial reference system, which is not used in this case. Below here you see brake pressure, anti-skid control, automatic braking control for takeoff and landing. In the middle here our screen to control our smoke detection system, miscellaneous smoke. We will discuss it later when we discuss the whole installation made after Halifax, so-called Modification Plus. Let's go to some basics. On the left hand side, center pedestal, parking brake handle with a control light down here. This is an alternate trim handle, longitudinal trim. Primarily we trim on the control wheel, but this is an alternate means. This is the speed brake handle and ground spoiler handle. In the middle, of course, 3 throttles and reverser control levers. Just below them, the engine starter buttons, 1, 2, 3, and the fuel switches. Further to the left, flap slat handle. It's quite a complicated mechanism to operate, and we have also a variable flap position, a so-called dial flap, we can control with this control wheel in a range between 5 to 22 degrees. Further down in the aft pedestal, let's start with the communication panels. There are 3 identical communication panels, number 1, number 2, and 1 is in the back down here. With these communication panels we operate 3 VHF communications, 2 HF communications, satellite communication, as well as the interphone communication within the airplane. In the middle, a little bit hidden below the fuel switches, is the control panel for the systems display, as we discussed before, brightness control of our 6 display units, and the buttons to select the corresponding page on the system display. Here is our third MCDU. We use it primarily for the operation of the ACAR systems, but in addition we also have access to the aircraft data acquisition system, a centralized fault and data systems, as well as our satellite communication system. Last but not least, weather radar control panel, ADC transponder, and in the middle, aileron trim, rudder trim, an ACAS printer, and the electronic door control of our cockpit door. I think that concludes the center pedestal of the MD-11. Okay, just some information about our intended approach into Buenos Aires runway 11, which is most probably our landing runway. We'll hear that later when we receive the ATIS information. I can show you down here the whole setup. I expect an approach. We come in from the northeast, usually straight to the field over the Asia VOR, and as I expect the runway 11 is now in the FMS is programmed this base turn to the south and turning in on an ILS approach runway 11. Very often, as the weather is very fine, you get visual approach clearances. The best thing would be to get direct to a left turn base and turn in visually on runway 11. You see the airport setup on this page. Buenos Aires has main landing runway 11 or 29 and mostly used for takeoff runway 1735, 3,300 meters or 3,100 meters long. Our parking position is usually in the vicinity of this terminal, international. So the best way for me would be a landing on runway 11, a clearance to turn into the runway 17 for taxi and leave via this taxiway number Charlie and park somewhere here. We will get by ACARS the information where our parking is. As soon as we have the ATIS, we'll do our approach briefing and discuss in details how we want to perform that approach. Okay, let's do the approach briefing. We expect ILS approach runway 11. With any option, visual approach 11, left hand, right hand, visual approach 35 would be the best option if we see the field. Anytime, feel free to call field insight and then we make visual approach for that, whatever we get. In the flight management system is programmed ILS runway 11, number 2 procedure. That goes overhead Buenos Aires, then base turn to the south, 10 miles, base turn right, 2,200 intermediate approach altitudes, glide path intercept 3 degrees at 6.7 DME ILS, outer marker Oscar Charlie 1350, and we set the minimum of 260 feet bottle. You are ahead. 260 is cross-checked. Runway 11 is 3,300 long, 60 wide. We, as discussed, reverse, no auto brake, and we try to get the clearance to turn into runway 17. In case of missed approach, straight at to 500 and a right turn, radial, no, track 125 to 3,000, then according ATC. With that low weight, we make a full cleanup. Setting is 3,000, heading about 125. Overall, the clearance limit right now is PAPIC, center sector altitudes are 3,000 feet all around. In the secondary flight plan, I have already programmed runway 35. That would be the option for a visual approach 35 if we get that. We can make direct to the outer marker or something like that for good distance information. Landing flaps, I take full flaps. Full. Yeah, that's it. Approach briefing is completed.
For descent now to flight level 100.
Leaving 350, we are descending 100, flight level 1, spaceline.
5% 100.
Teresa, continue turn left heading 120. Confirm when you intercept the localization.
Yes, we are clear to intercept the local lines. We call the established local lines as we stand for.
Roger. 8 nautical miles out is severe. Contact now. Tower frequency 118.6. Resume our navigation. Goodbye.
Goodbye, see you later, Swiss 94.
Minimum. 100. 50, 40, 30, 20, 10.
Oil checks.
On the ground 56. Is possible continue to the left via 35.
Yes, via 35, Swiss 94.
After to the left via taxiway hotel.
Via hotel, Swiss 94.
After.